In dynamic stability itself, last class we had seen phugoid motion and natural frequency for the phugoid motion, and natural frequency for the phugoid motion, if you remember, it was WPH. It was WPH, and it was, I think, root 2 G by V radian per second. This was the uh, what it is. This was the uh, angular velocity, or you can say natural frequency for the phugoid motion. Phugoid motion, right? Phugoid motion or long period oscillation, you can say. And you had written frequency, not natural frequency. It was given T divided by root 2 pi V natural frequency, and then time period also you had written TPH for the phugoid motion. It was root 2 pi V by G, something like this you got. Okay, last class. Now coming to the next, which is nothing but uh, Routh decrements. That is the one criteria. With the help of this, we can check the characteristics equation of stability. We have to check, and with the help of that equation, we have to check the different type of condition for the stability. For the stability, different type of condition, or with this we can check the motion criteria also, like it is short period oscillation or it is long period oscillation. Okay, it is like what type of motion, I mean, if imaginary root you are getting, then what will happen, what is the mean of real roots. So based on this question they had asked in exam, so I thought we should also go through it. So this is nothing but Routh criteria. Okay, Routh criteria, or we can say Routh decrement. Routh decrement. Okay, this is the basically criteria. So the equation for longitudinal, this is very important actually. So the equation for longitudinal dynamic stability. Okay, dynamic stability for given airplane, is known as characteristics equation. Characteristics equation, or or stability equation. Okay, stability equation, and it is given as, that characteristics equation is given as, what is the characteristics equation? So see, this is the characteristics equation basically. Characteristic equation, what we have, it is nothing but, see, the characteristics equation what we have, it is nothing but a lambda to power 4. Okay, lambda to power 4, b lambda to power 3. Okay, b lambda to power 3, b lambda to power 3 plus lambda to power 2 plus c lambda to power 2. Okay, plus d lambda plus e is equal to 0. All right, where a b c d are constant, where a b c d, a b c B and E are constant. Okay. Now, now we are going to check the longitudinal dynamic stability equation. Then we have to make a note for a few points. And what are the points? So following points should be noted, should be noted for 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 longitudinal dynamic stability equation. What are the points? Like whatever the equation you have written, for the same equation, A lambda to power 4, B lambda to power 3, C lambda to power 2, D lambda plus E0. What are the points? C. These points are very special. The points are all the coefficients should be positive. Okay. All the coefficients should be positive. Number one. Number two, B and C, B and C should be greater than D and E. D and E. A should be almost A should be A should be almost or exactly equal to 1. Okay, now this is the pattern of the uh, stability equation, or it is also called characteristics equation. So like all the coefficient like A B C D E should A B C D and E should be positive. A B C D and E should be positive. Okay, B and C should be greater than D and D. A should be almost or exactly equal to 1. So how that equation should look like? So that equation should look like this. See, just one example I am giving here: lambda to power 4 plus 5.05, lambda to power 3 plus 13.2, lambda to power 2 plus 0.67, lambda plus 0.59 is equal to 0. So now if you check what is the A here, A, if you compare, A is nothing but 1. All the uh, coefficient you can compare, A is what, 1, B is what, 5.05, C is what, 13.2, D is 0.67, E is 0.5, right? And if you check, A should be almost equal to 1, B and C should be greater than D and E. D and C is always greater than D and E. So all is condition is what satisfying. Okay, all conditions here if you check it is satisfying. Now, if question came for this characteristics equation, so like what are the different routes criteria we have? So that routes criteria you have to write. From the routes criteria question they are asking, and how question will be creating, that one question also will solve based on it. It's very simple. And if you check last 2-3 exams they had asked. Okay, so give the heading routes criteria. Routes criteria. Okay, just listen simple. What is the routes criteria? So what is the R? Basically, in case of routes criteria, we have to write the routes constant. What is the Raoult's constant? It is R. So for R, what is the equation in Raoult's criteria for R? R is nothing but Raoult's constant, Raoult's scientist name who has given this characteristics equation. So R is equal to BCD minus D square A minus D square. This is the value of R. Okay. Now listen, different cases we have. You have to learn these cases. Okay. So question easily you can solve. Now what is the case one? If this Raoult's criteria, if Raoult's constant R is greater than 0, then what is the mean of it? Very special meaning for this is, okay, so whatever the suppose stability equation they have given, now this is this stability equation, just for example, suppose they have given, okay. So with the help of this stability equation, what you will do first, you will calculate the constant. This constant you will get A, B, C, D, E, and this A, B, C, D, E, with the help of A, B, C, D, E, you just find out the Raoult's constant. This is the what Raoult's constant R. B, C, D, E, all here it is used, B, C, D, A, E. Okay, and from where you will get B, C, D, A, E, you will get from the characteristics equation. You compare and get that value. So from there you write Raoult's constant and you got R is greater than 0. What is the mean of it? It means R is what? Positive. That means R is what? Positive you are getting. Then point number 1, you remember this is now answer. Question will be asked, so from this point you can get answer. So it shows if R is greater than 0, then it shows it, these points you need to remember, it shows dynamically stable. Okay, so they will give one characteristics equation, and from there immediately you just find the Raoult constant. If you are getting positive, then you can say, okay, whatever the characteristics equation or longitudinal dynamic stability equation is given, with the help of this you can say this, if R is greater than positive, then you will say it is now dynamic stable condition. This is the dynamic stable condition. This is the point 1 you got in case 1. Number 2, what is the number 2 point? Roots of the characteristics equation will be complex pair with negative real parts. Okay, like how that equation you will get, that also you need to write. This is the second point. Roots, we'll solve one question, don't worry, so it will be more clear. Roots of the characteristics equation. Characteristic equation will be complex pairs with negative real parts. Real meaning will be very simple. I can just for example I can give the equation also. Just for example, like if R is greater than 0, then roots, because this is what power 4 equation. Okay, so here you will get the roots of characteristic equation, and it will be the pair of what real and imaginary part will be there. So that is complex pair basically. So in complex pair, obviously in complex means real and imaginary both are available, but in complex pair, whatever the real part, it will be negative only. Okay, so you just see the example. So like two pairs you have to write complex pair. First I'm writing here minus p1 because they said real part is what? Negative. See, negative, real part is what? Negative. So minus p1 plus minus, this is the complex. How to write the complex value? It is x plus minus iy. This is the complex, right? So x is what? Real, and y is what? Imaginary. So here real is nothing but p1, and it is clearly mentioned if Raoult's criteria, Raoult's constant is what? Positive, then your real part will be negative. So minus p1 real part, and then plus minus I imaginary part, and then q1. This is the first roots you will get. Second root you will have a minus, because real part should be negative, so it is minus p2 again plus minus I q2. So these two roots you will get. Okay, and both roots will have the real part will be negative. Okay, that is the second point. Third point, what is the third point here? In third point, all the modes are periodic and damped. Modes, all the modes are periodic and damped. This is the point 3. Point 4. Point 4 is nothing but is generally has two modes. It generally has two modes. Okay, that is phugoid and short period oscillation. So it's very clear when phugoid motion or short period oscillation will occur when Raoult's constant will be positive. Then both that two modes will be available, phugoid and short period. Okay. Phugoid means long time period and short period means obviously a short time period. So with the help of that modes, with the help of that time period only, you can say this is the phugoid motion equation and this is the short period motion, depends on the value of the time period. Okay, anyway, so this is the fourth point you got. Now we are having case 2. So what was the case 1? Case 1 was the r greater than 0. Case 2, what we have, Raoult constant, it becomes 0. Then what is the mean of? Just listen, it's very important. So if Raoult constant is what, 0, then it, what it represent, it represent dynamically neutral condition. Dynamically neutral. So if r is equal to 0, then it means it shows that it dynamically neutral condition. If r is what, greater than positive, greater than 0 means r is what, positive. If r is what, positive, then it's dynamically stable. If r is positive, then it's dynamically stable. Here it is given. But if r becomes 0, then it means it is dynamically neutral condition. So again, that points you need to remember for this also. This is, it shows dynamically neutral condition, r is equal to 0. It represents dynamically neutral condition. Okay. Now third case better we write. I'll tell you about case 2. When it is neutral, then what will happen? Again, once we'll solve one more problem, then you will understand what is the important. Basically for that cases I'm writing. So case 2 done. Now case 3 you go. What is the case 3? If r is less than 0. This is important. Okay, this is important. So if r is less than 0, okay, if r is less than 0, then what will be the mean of it? Number 1, first it shows dynamically unstable condition. So theoretical question also they can ask, if Raoult constant is what, positive, then dynamically stable or unstable, or they can ask if Raoult constant is 0, then it is dynamically stable, unstable, neutral, none of the above. Also they can ask if Raoult's criteria or Raoult constant is what, less than 0, which means negative, then it is dynamically stable. Option 1 stable, option 2 unstable, option 3 neutral, option 4 none of the above. So for that time also you need to remember this. If you remember, then you will be able to answer. Okay. Now coming to this. So what is the point? For this we need to write the point. If r is less than 0, that means Raoult's criteria is what, negative here. Raoult's constant is what, negative. So first it is the dynamically unstable condition. Okay, and this case, one of the roots having complex pair with positive real part represents an undamped oscillation. So suppose we are getting roots, if 4 power 4 is there, then 4 roots will get. If 3 power is there, then 3 roots will get. If 2 power is there, quadratic equation, then 2 roots will be there. So like in previous case, I had shown you, basically definitely 4 power is there, so 4 roots will be there. But in 4 roots, 2 roots of the characteristics will be the complex pair. At least 2 roots will be the complex pair. So here I have written. Similarly here, if r is less than 0, then obviously 4 power is there, then 4 roots will be there. But among 4, at least one complex pair will have. So in case of, here I will write, in this case, number 1, in this case, in this case, one of the root, one of the roots having complex pair with positive real part. Okay, represents undamped oscillation, represents undamped oscillation. Example, what is the example of the equation? Here it is said at least one complex root will be there, and then real part represents undamped. It will be positive actually. So just one complex root I want to show. Suppose this is p1 plus minus I p1. So at least one complex root here we should have, and there the real part will be positive, and this positive real part will represents undamped oscillation. Okay, and the next point for this, the other pair represents, the other pair represents undamped oscillation. Other pair represents a a phugoid or short period oscillation. One big numerical will solve, then it will be more clear to you. Okay, right. Now case 4, we are going for the case 4. Total 5 cases we have. Okay, so uh, case 4, what we have here, case 4, what is the case 4? If e is equal to 0, where is the e 0? That this part, no, characteristics equation, where is e? So if you check the standard equation, this is the e. So if this part is what not there, it is 0 only, then what is the mean of it? So okay, if it is there, then its meaning is one of the value of lambda is 0. One of the value of lambda is 0, which shows one mode is dynamic unstable. One mode is dynamic unstable. This is point 1. Second point, which is very important. What is the second point? Second point we have, if other roots are negative, if roots are negative, then then it shows pure convergence. Okay. And the third point is if other roots are positive, then it shows it shows pure divergence. So if other roots are positive, then it will be divergence, and if other roots are negative, okay, if others roots are negative, then it will be the pure convergence. This small point you need to remember, because they are going to ask in exam. Okay, theory question will be asked from the Rouse criteria, so many question we can make here. Okay, at least in test I can create multiple question from this theory Rouse criteria. Okay, it's very single marks question, easily they can ask. Okay, they can give the characteristics equation and they make e is equal to 0. Okay, and once e is equal to 0, so they will ask like, okay, at least one value of lambda will be 0, first option. Second option, at least one value of lambda will be infinite. Third, at least one value of lambda is positive. Fourth, at least one value of lambda is negative. Like that question they can ask. Okay, so we can create simply question we can create here. Now now coming to the case 5, in initial I, what I told you, like all the here all the coefficients should be positive. This point I have given here, all coefficients should be positive. But case 5 is what if any coefficient in the characteristics equation has negative sign, then what is the mean of it? Then at least one of mode will give pure convergence or dynamically unstable condition. That also you need to remember. Simply they will give characteristics equation and they will ask question, so you can answer for this. What is the next case? Case 5. Okay, case 5. What is the case 5? If any coefficient in the characteristics equation has the negative sign, one of the modes will give pure convergence or dynamically unstable condition. Right, these are the points you need to remember. And and here few things like in examination till now they have not asked, but they can ask. Okay, they can ask. So I have to give the formula for that, and you just make a note, and then we'll solve one problem. So each and every points will be clear to you. Okay, like three formula related this I will write here, like time period. If they are interested in time period, and they will give the characteristics equation and they will say calculate time period. So what is the formula for that? You just see. Okay, so what is the time period formula here? time period capital T. Okay. So what is the time period capital T? T is nothing but it's a 2 pi T, okay, divided by Q mod, and it's a T cap. Okay, so what is this T cap? Actually, this T cap, all the data you need to write here. All the data you need to write here. What is the T cap? T cap is nothing but M upon rho Vs. M upon rho Vs. And what is this T? This T is nothing but airplane density factor. Airplane density factor, right? And if you check here all the value, like what is M? So M is simple as usual. M is nothing but mass of airplane. Mass of airplane, as usual symbol we have here, mass of airplane. Okay. And if you check what is the rho, the rho is nothing but free stream density. Free stream density. Okay. What is V? Free stream velocity. What is S? Wing area. And what is Q? Here I have given Q. See this Q value denominator. So what is the Q? Okay. So Q, or like in our standard formula I had denoted by capital Q also. So Q is nothing but it's the imaginary part. What is that? Imaginary part of root. And what is P? P or small p, what is the P? P is nothing but real part. Okay, real part. Now this is the formula here you have written. Okay, so you have written the value of time period. Okay, now coming to the time to half, if they have asked time to half. Okay, question will be asked like, okay, calculate the time period, time to half, number of cycles, like that question will be asked. Okay, so what will be the time to half? Time to half of the complete cycle time period. So time to half you can write here, time to half. That means it's they are talking about time period, time to half. It is nothing but minus 0.693 T cap divided by P. P means real part. If they ask time period, then you have to take Q in denominator, and if they have asked time to half, then you have to take P in denominator. Okay, and check the formula in numerator also. Okay, so this will be the formula for time to half. All right, the one last formula which is called number of cycle to half. Okay, number of cycle to half. This is the third formula. Number of cycle to half. Okay, it is nothing but number of cycle to half. So what is the number of cycle to half? For this, what is the formula? So for that we have formula number of cycle to half 1 by 2 is equal to natural frequency into time period to half. This is the formula. And you know very well what is the natural frequency. So Fn is nothing but what? It's omega n divided by 2 pi. Omega n is the angular velocity, or you can say natural frequency in radian per second. Fn is the natural frequency in hertz. What is the unit here? This is also natural frequency, but it unit will be hertz, and this is also natural frequency, but unit is what? Radian second. So what is the number of cycle to half? n by n1 by 2 is nothing but fn t half. Okay, now the all thing is what done. Now you will get one problem, and once we'll solve this problem, then whatever I have discussed till now, it will be more and more clear to you. It will be more and more clear to you. Okay, the one problem you solve, then everything will be cleared. Now what is the problem? So you just write problem number 1. Okay, the problem is, question is the quartic. Quartic means power 4, na? The quartic of of longitudinal dynamic of an airplane, of an plane is given as what is the equation? Now we have the equation is, this is the equation they have given, lambda to power 4 plus 5.0159 lambda to power sorry 5.0, just if you bracket, then you will get the power 4. Here whatever the equation we have, the given like this, see, but the meaning will be same. Okay, if you do that, then you will get it. See, the airplane is given as, okay, as, now what is the equation they have given? Equation as lambda square plus, actually standard format this they have given, but you have to convert in power 4, so it will be more easy for you. Lambda plus 12.984 in one bracket, second bracket it is lambda square plus 0.034 0.03406 lambda plus 0.0454 bracket and equal to 0. This is the equation. Okay, this is the equation. So I'll write again, not here for me. Whole equation I will write here. Whole equation will write here. What is the equation? Now we have lambda square plus 5.01 9 lambda plus 12.984 in one bracket, another bracket we have lambda square plus 0.03406 lambda plus 0.0454 bracket. This is the quadratic equation, means power 4. Now if you open this two bracket, do some multiplication and all, then what you will get? You will get lambda to power 4, the main equation you will get. Now but this is the equation, suppose they have given to us. Now what they are saying? They are saying calculate. They are saying calculate the time period, time period, time to half, number of cycle to half, identify, okay, identify the modes and 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 compute the damping factor and natural frequency of the modes. This is the complete question. Okay, this is the complete question basically. This is the complete question, right? Okay, now now if you check here, first they have asked calculate the time period, time to half, number, half cycle to half, identify the modes, and complete the damping factor, natural frequency. So this damping factor, natural frequency, for what they are asking. Obviously figured motion will come into picture. So you have seen I had given damping factor formula, and I had given the natural frequency formula, maybe time period of the natural frequency figured, or time period for the short period oscillation also. Okay, short period oscillation also you can calculate. So each and everything you can calculate. Also here they have given modes, how to find what type of motion is there. In longitudinal dynamic stability, basically two types of motion we have: short period and long period. So for the short period they can ask calculation, find out natural frequency, find out damping ratio or damping factor. And similarly they can ask for the pivot motion also, because both are the oscillatory motion. One is short period oscillation, another is long period oscillation, or large period oscillation, or long period basically oscillation. But oscillation is there. So in both cases they can ask time period, they can ask number of cycle to half, they can ask time period to half, they can ask damping ratio, they can ask natural frequency, they can ask time period also. So question they can ask. Okay, so similar kind of question they had asked in exam also. From they will give the one equation, and some real and imaginary roots will be there. With the help of real and imaginary roots, we have to define this roots is what representing figured motion, or this root is what representing the short oscillation, something like that. So we have to identify it. Okay, so this will be one question. Whatever the theory I have given here, based on this theory only we have to solve this question. So you can try this. If not, then I will able to solve. I will solve this, but I want you to solve first from this first point. This is the Routh criteria. You have to check this equation, and you have to convert this equation in lambda to power 4 and lambda to power 3 and lambda to power 2 and lambda. In this format you have to convert your equation, because we have two brackets here. You can check two brackets are there. So two brackets you have to break and open and just convert into standard format of the equation. This bracket you have to break and convert lambda to power 4, and then start comparing with this equation to the all coefficient A, B, C, D you have to calculate. Once you calculate A, B, C, D, suppose you have calculated A, B, C, D, then just go for the Routh constant. Check R value. R is you are getting positive, R you are getting negative, R you are getting 0, or whatever the condition you are getting. Just find out. Suppose you are getting Routh constant R is equal R greater than 0, means positive value, means 4 or 5 you got. So this is very clear. Now this is dynamically stable, and then you have to find the roots also. Check two roots pair will be there, real and imaginary parts. From the here you can check it is short period oscillation or long period. So this is the one process, lengthy process. But in examination, as I told you, this lengthy question, lengthy equation will be given to you, but question, very simple question they will ask. Suppose this equation they have given, they will not ask everything like what I have asked. They will not ask everything. They will simply say this characteristics equation of the longitudinal dynamic stability represents dynamically stable, dynamically unstable, figured motion, or short period oscillation. Something like this question will be asked to you. So, but if you know the criteria, you can hit the questions. For that reason, all the theory parts I had first explained. But in examination, one simple part will be asked to you. Okay, so don't worry. This will be the things. All right. This will be the things. Okay. Done. So should I stop now here? Yeah.